My name is Joachim Jansson. I work at Boliden. We're a mining and smelting company based mainly in the Nordics, so Norway, Sweden and Finland, but we also have mines in Ireland and now in Portugal as well. And I work at something called the Digitalization Hub in Boliden. I work mainly for the mine side of the company, but I work with everything from some AI applications up down to getting telemetry data from our mobile machines that are running in our mines. So it's quite a broad area.
Okay, cool. Yeah, so I guess a big topic here today also with Mark Donovan's session. We spoke a whole lot about a lot of organizations, struggling to sort of like break out of the pilot sort of like phase of implementation. So I want to get a sense, like from your case, sort of like what guardrails help you decide, which pilots do you sort of like green light? How do you scale out to sort of like your entire enterprise?
Yeah, so like getting from a POC into production, I guess, is really a $1 million question. And I think like in Boliden we actually test a lot of technology, we test a lot of system. We both develop like internal products, but also test a lot of things together with vendors. And I do think we have like some challenges in moving from POCs to production, but we also have some examples of successes in this area. I would say that you could do POCs in the sense of like not every application has to be moved into production. Some tests of technologies are actually okay that they fail. And I think actually it's important to like test things. With that said, obviously everything can't fail. Some things has to actually produce value and be moved into production. Some like pointers that I feel are sometimes problematic, and I think speakers have already been touching on this today, that I will focus on the first, the value proposition of some kind of system that you are testing or developing. I feel that generally there's a risk of people looking at the value proposition in the beginning of the journey. You create some kind of value proposition for your test or your system that you're developing, and you start a project, and then you hang everything on that value proposition. And you keep going and moving, and along the road, you don't really look back at that value proposition. You just feel that, but this is still the value proposition that we are building forward. And there's really large risks with that, in the sense that the chance that you have fully understood the problem that you are facing is quite low. And because of this, probably your value proposition that you have initially based your project on is probably wrong, and it will change along the road as you develop your project or your system. So I would say constantly go back to your value proposition, check, is it still valid? Has there been like new things that have changed that make it that change the value proposition? Have you seen that managing the system has turned like more complicated than you initially thought? So go back to the value proposition and check if it's still valid, update it, and then take new action based on how this changes. Because at least from my experience, this will change. This will change through the entire project all the time. Because if you have a hard problem, it's really hard to like create a demand definition in the beginning of the project, just saying like, yes, this is how we're going to streamfold this entire process, this entire project, and we will succeed with that. Another part that is quite similar, but I would still say different, is like the actual understanding the actual problem. So in Boliden, we're an industrial company, and we have operators that we mainly focus on, like making like product or system that can help in the production of ore, basically. And so basically, if there's some kind of problem that we want to solve, usually like you try to talk to operators and gather information about the problem, and then you start working on a project. And here I think sometimes I feel that from the IT side, we don't fully do or take our responsibility, in the sense that just because you have received a demand for how a system is supposed to be built, or a problem that an operator actually has, if you then go to your chamber and for 6 months build something, and then you come back and try to deploy it, and they just say like, well, this isn't solving my problem. There's some people saying that, okay, but you gave me the problem definition, so I've done my part. This is actually on you. I would say that that's really not constructive. Instead, I would say like, try to really dig down into the problem, and also here revisit the problem statement. Like, have we really understood the true problem that have been presented to us? Have things changed along the way? Have technology changed along the way? Have we gotten new insights? Because maybe the problem definition, maybe we didn't know when it comes to data, for example. Let's say that we are trying to stop a conveyor belt because of unwanted objects that are running on that conveyor belt. And we, from the beginning of this project, we get a definition saying like, okay, there will probably be like 20 objects that per day that will be valid to shut down the conveyor belt for. But along the way, in their project, suddenly there's 80 objects, there's 100 objects. And suddenly you learn that it takes 15 minutes to remove each object at a stop, where suddenly your conveyor belt is not running at all.
Yep.
What do you do then? Yeah, you have to go back constantly and talk to the operators, talk with stakeholders about what you find out while you're working. Have things changed? How do we go from here? Are there actually feasible solutions to the problems? Can we do it another way? So don't build something in your like back room in your chamber and think that you are taking responsibility for like sit with operators. I would actually say like don't interview operators in like in separate sessions. I would say talk to operators while they are doing their work. Sit with them in the process. And some people would say, oh, they don't have time for that. But I would say like in Boliden, our operators do a lot of things, and at least they have the capability to do their job and actually talk almost at the same time.
Yeah.
So talk to your operators, and I think usually they will really appreciate it. I think they will appreciate you being there, seeing them in their actual environment that they're working, because they're not working in a conference room where you're trying to interview them. They're working on the shop floor doing stuff. It depends on the the size of the sites, but if the sites are of a little bit bigger size that they can have their own IT department, we generally split it up at where system becomes critical for the processes to run. So if a system is critical to that it has to run, and basically most of the time the discussion comes down to if we lose internet connection or if we lose connection to the central Boliden servers, what processes still has to be able to run if that happens. And also then from that, there will be services that local IT will have to manage, because if central is down or we lose connections and there are services that IT has to manage, then that very clearly falls into the local IT domain. Historians really clearly falls into the central domain, I would say. At least you're like a central historian. I would say that an MQTT broker, it's an interesting thing, because I think as you build applications that are critical, that end up on your broker, let's say you have a site broker that you're utilizing, that really falls somewhere in a mix, I would say. Probably you would have some local ownership of some things to be able to manage certain things in the process while running. And then you would have help probably from a central organization with deployment of like smart ways to deploy and things like this.
Okay. Yes, I mean, also a part of it is on the the clash of cultures, right? Mm-hmm. So I wanted to sort of like give us maybe if you have like an example of how you are navigating that sort of like cultural differences. OT has always had a way that they do things. IT has always had that way. And then a lot of times with digital transformation, you get teams with representation from kind of like both OT and IT. How do you sort of like navigate those cultural challenges?
So that is challenging. I would say that I think it's a lot of companies in Sweden are like this, but also like mainly I'm from Boliden, so we are really based in the sense that we want to drive consensus. So we don't really force things downwards. Rather, we try to build consensus between IT and OT. And obviously, this can be challenging in some instances. But I do believe that, like with new tools and the new possibilities that are developing, you really have to like dedicate yourself in having conversations together to try to move forward with digitalization, because the value is created on the shop floor. So if you don't digitalize on the shop floor, then like what are you doing? Like you can't just say that we're only going to work with economics. Like in the end, the value is created on the shop floor. So you'd really try to have to talk to each other, try to build consensus, try to build really like use cases that can champion digitalization, that can really be used as examples that, okay, that works really well. And that's an IT-OT collaboration project that you can actually point to, that can we actually afford not to do that? Can we like say that, no, we should just separate it? So generally we do have some sites where we have IT and OT working in the same team. And we have sites that they're quite good communication between IT and OT. But me personally, I probably think that IT and OT should probably be united in the same team together, especially with like all of the technology that's coming out. Probably I would say that maybe it's a clearer split in IT between like close to production IT and really centralized IT. Maybe that would be a more natural split rather than IT and OT, because I think that it costs a lot to have that split. Yeah.
Okay. Yeah, I guess the other thing that I want to sort of like get your sense on is, I mean, the big reason why a lot of people are here today is we tend to talk about unified namespace at a more conceptual level, kind of like buzzwordy. So maybe I want to get your sense on what, as you start to sort of like implement the unified namespace, what have you seen as kind of like the biggest surprises or misconceptions that you've seen out there but don't really, apply in the real world? Do you have like any specific things that come to mind?
I do think that the speakers that have already talked today have brought up really valid points. Maybe one thing that I would like focus in on that maybe have not been raised today is like if we're thinking of using machine learning or more advanced analytics on data we're gathering, I think that we should put certain like focus on, and now, sorry if it gets a bit technical, but like basically try to get really good quality on your why values that you're going to use as your like truth when you're doing analysis. I wouldn't put as much emphasis on building high data quality on your X values because there's a lot of ways to manage that. But getting high quality in your Y values is quite critical, and try to like think of ways to do this and invest maybe in high quality sensors that will give you this. For example, we have mobile machines running in our mines. And a lot of like things when it comes to data is like, oh, we want to predict when we will have breakdowns of our machines. And that's really problematic because we don't really have good Y values on when a machine is actually broken. Like we can suspect that machines are broken, and maybe there's been an entry in like a service manual or something like this that, oh, the machine is broken because of this and this. But probably the timestamp is wrong on when the machine actually broke. Probably there's really a wide description of why the machine has broken, and so on and so on. And this will be really hard to build anything upon this data. Some things that we are looking into is then instead try to find ways to detect the true state of breakage. For example, we're looking into smart bolts that can basically send via BLE communication, can indicate if the bolt is tightened or not, or if it's broken or not. And then you have a true Y value. And then you can look via that Y value at creating more advanced analytics. And I really do see that it fits really well into the unified namespace on having constant reports from your mobile machines of the state of these bolts, or for that matter, other kind of states that can indicate breakage that is really like a good Y value to use, that is high quality and that truly indicates the state of this type of things you're trying to detect.
Awesome. Okay, so I've got a few more questions here, but I want to give an opportunity to the audience here if you want to ask any questions. So I'm going to ask one more question. In the meantime, you could prepare some questions that you may have for Joachim here. So yeah, I mean, as far as vendor and technology selection is concerned, do you have some minimum technical requirements that you're working off of?
Yeah, so like when it comes to what I am involved in when it comes to like setting specs for equipment that we are buying, it's mostly in the mobile machine area. And there we are really trying to strive, even though it's quite hard because there are vendors have really probably not the same motivation as us when it comes to making sure that we own the data from the machine, that we can get it in an open, clear format, and that we can get the data that we want. Generally, we try to set it like we want to use open protocols. So we don't put like MQTT as a hard spec, but we usually point towards it because we are already using it. We have brokers on site, but we don't want to say that, no, this is the only thing we're going to use. But we do. A lot of it leads to that. I would say that like when it comes to Spark V, it's really interesting from the mobile machine point of view because of in the spec, basically you report when you are birthed onto the broker, you report all of the possible data points that you will ever deliver. And this is actually like really important for a mobile machine because it has really a lot of errors that will only like be reported once or twice, if ever. And if you have a historian that is going to consume and you don't have Sparkplug B messages, or if you don't have something that's telling your historian to expect certain values, that is like really problematic. For example, if you're scraping with like in Aveva Pi, if you're scraping with their MQTT connectors, it will only consume the values that will actually be sent during a specific time limit. And some of these values will maybe be sent once a year. So then you won't consume those messages. But if you have Sparkplug B, that will clearly define everything that you will ever get. Everything works like by itself. So in that sense, Sparkplug B for mobile machines are actually really, really nice. But basically, there's not many vendors that have integrated with Sparkplug. So if you even can get them to an open protocol like MQTT, you are actually really happy. But it would be super nice if more vendors would use make it possible to use Sparkplug B. It has its shortcomings, but it also, in some sense, it has a really good strengths as well. So we are talking about it. I haven't specifically used it myself, but we are looking with some vendors that want to use it. I personally don't see a big problem with using it. Like, so I'm pretty fine with using it, but yeah, I don't have too many thoughts around it, so to say. Probably it's really good in a DCS system to use it. Probably it doesn't fit very good on like a mobile machine network where you have bad connectivity and so like things like this. But I will have to try it out more before I can really give some. Yeah, so we have a use case that quite recently went into true production, where we are detecting unwanted objects on conveyor belts. I referenced it a little bit. So we are basically detecting large bolts that we use to strengthen the mines, so we won't have like collapses. We also detect other objects like wires and large rocks. These objects can cause blockages when they are running on conveyor belts. They can also, if you're unlucky, you can get the situation where a bolt gets in a situation where it starts cutting the conveyor belt. And if it cuts the conveyor belt, well, then you are in total down, then you can't move any ore, and then you really have to scramble to get the conveyor belt back up and running. So reducing the amount of incidents where this can happen, because then we have a dedicated area where we can actually shut down the conveyor belt and remove objects without actually lowering the throughput of our mill, because we have an area where we can store ore before this conveyor belt, and we have a possibility to store afterwards. And this conveyor belt is running faster than the skipper that is bringing up ore. So we have for every skip we have 30 seconds, because we're running 30 seconds faster. So we have 30 seconds time to like do stuff that without actually causing downtime. And we actually did, so from the beginning we saw that we thought we only had like a small amount of objects, but actually after working with this project, we actually saw that we had a massive amount of objects, like twice or three times as many objects that we actually really wanted to remove. And this integration, IT-OT integration, actually has turned out really well. They are really happy with it. And I think that like a true testament that they are actually happy with it is that we are stopping the conveyor belts twice or even three times as many times a day, and they are still okay with that. Like If it's a system that you're only like watching for some kind of analysis, it can be really hard because people can say, oh yeah, we're happy with that system, but we don't really use it, is the truth. This system stops conveyor belts, and if people are still happy with that, well, that's a super awesome outcome. Yeah, so this is really interesting in the sense that we built up statistics on one of the big things that were discussed is that there was quite a strong opinion on how many objects were running on the conveyor belt, but we didn't have like truth like around that. There was just feelings and considerations, and we had an older sensor that we knew were missing some objects. So we knew we had at least this many objects, but we didn't know like the upper limit of the amount of objects. And this, you really have to like feel what kind of evidence is it that the managements and operators are actually looking at. We actually failed in the beginning to like actually because we built up like statistics and reports around this, and this was not very well received, in the sense that we were not really communicating in a good way with both management and operators. The thing that turned that around, and that was actually much more helpful, was trying to run simultaneous, like we were basically running the system on the side, sitting with operators while they were working, and having like, okay, in this situation, this happened, this system would have done this, and this and this, and they actually appreciated that a lot more, because also here there can be like, operators can probably feel that there are certain situations like, have you really considered this? But if they see the system running as a ghost on the side, they can actually, oh yeah, okay, it works in the manner that I think the process should work.
Okay, so maybe one last question from me. What's your view or approach as far as standards are concerned? So whether it be ISA 9-5 or PCBA?
Probably it will be ISA 9-5, but also this is like things that we will have to like internally talk a lot about to actually reach a consensus about, I think. But it's so ongoing discussion.
Okay. Perfect. All right. I think if we've got no more questions, we break for lunch. So, a round of applause.